question concerns the requirements for a disconnect for an electric stove that is cord and plug connected. The available information does not provide specific guidance on whether a disconnect is required to be within sight of the appliance. Electrical codes, such as the National Electrical Code, or NEC, establish safety standards for electrical installations. These codes are adopted and amended by local jurisdictions such as states, counties, and municipalities. Therefore, the requirements for disconnects can vary depending on the specific location. Generally speaking, a disconnect is a switch or circuit breaker that allows you to energize an appliance or electrical circuit for safety purposes, such as during maintenance or repairs. The NEC often requires disconnects for appliances to be readily accessible and located within sight of the appliance. The purpose of this requirement is to ensure that the person working on the appliance can easily de-energize it and verify that it is de-energized before beginning work. However, there are exceptions to this rule, and the specific requirements for disconnects can vary depending on the type of appliance, the voltage, and the amperage of the circuit. For example, a cord and plug connected appliance may not require a disconnect if the plug is readily accessible and serves as the disconnect. To determine the specific requirements for a disconnect for an electric stove in a particular location, you should consult the local electrical code. The local electrical code can be obtained from the local building department or electrical inspector. You can also consult with a qualified electrician who is familiar with the local electrical code. An electrician can assess the specific situation and provide advice on the appropriate type and location of disconnect. In addition to the NEC and local electrical codes, there may be other regulations or standards that apply to the installation of electric stoves. For example, the manufacturer of the stove may have specific requirements for installation and disconnects. It is important to follow all applicable regulations and standards to ensure the safe and proper installation of the stove. When installing an electric stove, it is also important to consider the size of the circuit breaker and the wire gauge. The circuit breaker should be sized to protect the circuit from overloads and short circuits. The wire gauge should be sized to carry the amperage of the circuit without overheating. The NEC provides tables that specify the appropriate wire gauge for different amperage ratings. It is important to follow these tables to ensure the safe operation of the circuit. Electric stoves typically require a dedicated 240-volt circuit. This means that the stove should be connected to a separate circuit breaker in the electrical panel. The circuit breaker should be sized to match the amperage rating of the stove. For example, a stove that draws 30 amps should be connected to a 30 amp circuit breaker. When connecting the stove to the electrical circuit, it is important to follow all safety precautions. Turn off the power to the circuit breaker before beginning work. Use insulated tools to avoid electric shock. Connect the wires to the terminals securely, and double-check all connections before turning the power back on. If you are not comfortable working with electricity, you should hire a qualified electrician to install the stove. An electrician can ensure that the stove is installed safely and in accordance with all applicable codes and regulations. In summary, while the provided information does not address the need for a disconnect in sight of an electric stove, the NEC and local electrical codes typically require disconnects for appliances to be readily accessible. Consult the local electrical code and a qualified electrician to determine the specific requirements for a disconnect in your location. Ensure the safe installation of the stove by following all applicable regulations and standards, and by using appropriate wiring and circuit breaker sizes. The NEC provides detailed requirements for electrical installations. For example, NEC Section 210.8 addresses ground fault circuit interrupter, or GFCI, protection. GFCI protection is required for receptacles installed in certain locations, such as bathrooms, kitchens, and outdoor areas. The purpose of GFCI protection is to protect people from electric shock. A GFCI is a device that detects ground faults and interrupts the circuit if a ground fault is detected. Ground faults occur when electricity flows through an unintended path, such as through a person's body. GFCI protection is required for receptacles that are located near water or in areas where people are likely to be barefoot. NEC Section 250.50 addresses grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which allows the circuit breaker to trip and energize the circuit. Bonding connects all metal parts of the electrical system together, which helps to prevent voltage differences between the metal parts. Voltage differences can create a shock hazard. Grounding and bonding are required for all electrical systems. NEC Section 300.11 addresses securing and supporting wiring. Wiring must be properly secured and supported to prevent damage and to ensure that it does not create a hazard. Wiring can be secured with staples, straps, or other approved methods. Wiring must be supported at intervals that are specified in the NEC. NEC Section 310.15 addresses ampacity of conductors. Ampacity is the current carrying capacity of a conductor. The ampacity of a conductor must be sufficient to carry the load that it is intended to serve. The NEC provides tables that specify the ampacity of different types of conductors. The ampacity of a conductor is affected by several factors, including the size of the conductor, the type of insulation, and the ambient temperature. NEC Section 400.8 addresses use is not permitted for flexible cords and cables. Flexible cords and cables are not permitted to be used in certain applications. For example, flexible cords and cables are not permitted to be used as a substitute for fixed wiring. Flexible cords and cables are also not permitted to be run through holes in walls or ceilings. NEC Section 406.4 addresses general installation requirements for receptacles. Receptacles must be installed in accordance with the NEC. Receptacles must be securely mounted and properly grounded. Receptacles must also be protected from physical damage. NEC Section 408.36 addresses overcurrent protection. Overcurrent protection is required to protect electrical circuits from overloads and short circuits. Overcurrent protection is typically provided by circuit breakers or fuses. The size of the overcurrent protection device must be matched to the ampacity of the circuit. NEC Section 430 addresses motors, motor circuits, and controllers. Motors are used in a wide variety of applications. The NEC provides detailed requirements for the installation of motors, motor circuits, and controllers. These requirements are intended to ensure the safe and reliable operation of motors. NEC Section 440 addresses air conditioning and refrigerating equipment. Air conditioning and refrigerating equipment often requires special wiring and overcurrent protection. The NEC provides detailed requirements for the installation of air conditioning and refrigerating equipment. These requirements are intended to ensure the safe and reliable operation of this equipment. NEC Section 500 addresses hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC provides special requirements for electrical equipment installed in hazardous locations. These requirements are intended to prevent the ignition of flammable materials. NEC Section 517 addresses healthcare facilities. Healthcare facilities have special electrical requirements to protect patients and staff. The NEC provides detailed requirements for electrical systems in healthcare facilities. These requirements are intended to ensure the safe and reliable operation of medical equipment and to protect patients from electric shock. NEC Section 547 addresses agricultural buildings. Agricultural buildings often have special electrical requirements due to the presence of livestock and the potential for exposure to corrosive materials. The NEC provides detailed requirements for electrical systems in agricultural buildings. These requirements are intended to ensure the safe and reliable operation of electrical equipment and to protect livestock from electric shock. NEC Section 600 addresses electric signs and outline lighting. Electric signs and outline lighting often require special wiring and overcurrent protection. The NEC provides detailed requirements for the installation of electric signs and outline lighting. These requirements are intended to ensure the safe and reliable operation of this equipment. NEC Section 625 addresses electric vehicle charging systems. Electric vehicle charging systems are becoming increasingly common. The NEC provides detailed requirements for the installation of electric vehicle charging systems. These requirements are intended to ensure the safe and reliable operation of these systems. NEC Section 680 addresses swimming pools, fountains, and similar installations. Swimming pools, fountains, and similar installations have special electrical requirements to protect people from electric shock. The NEC provides detailed requirements for electrical systems in these locations. These requirements are intended to prevent electric shock and to ensure the safe operation of electrical equipment. NEC Section 690 addresses solar photovoltaic, or PV, systems. Solar PV systems are becoming increasingly common as a source of renewable energy. The NEC provides detailed requirements for the installation of solar PV systems. These requirements are intended to ensure the safe and reliable operation of these systems. In addition to the NEC, there are other standards and codes that may apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the American National Standards Institute, or ANSI, and Underwriters Laboratories, or UL. It is important to be familiar with all applicable standards and codes when designing and installing electrical systems. The NEC is updated every 3 years. It is important to use the most current version of the NEC when designing and installing electrical systems. The NEC can be purchased from the National Fire Protection Association, or NFPA. The NFPA also offers training and certification programs for electricians and other electrical professionals. When working with electricity, it is important to always follow safety precautions. Turn off the power to the circuit before beginning work. Use insulated tools to avoid electric shock. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and in accordance with all applicable codes and standards. In conclusion, understanding electrical codes and standards is essential for ensuring the safety and reliability of electrical installations. The NEC provides comprehensive requirements for a wide range of electrical systems and equipment. By following the NEC and other applicable standards, you can help to prevent electrical hazards and ensure the safe operation of electrical systems. Always consult with a qualified electrician if you have any questions or concerns about electrical work. They can provide valuable advice and assistance to ensure that your electrical system is safe and code compliant. The information provided here is for general informational purposes only and does not constitute professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Doing so ensures adherence to local regulations, safety protocols, and best practices in the electrical field. Furthermore, a licensed electrician can assess your specific circumstances and provide tailored solutions for your particular needs. Failure to follow electrical codes and safety precautions can result in serious injury or property damage. Therefore, it is always best to err on the side of caution and seek professional assistance when dealing with electricity. Electrical work should only be performed by qualified and licensed individuals who have the necessary training and experience to do the job safely and effectively. Remember to prioritize safety and consult with a professional for all electrical work to prevent accidents and ensure compliance with applicable regulations. The importance of consulting with a qualified electrician cannot be overstated. Their expertise and knowledge are invaluable in ensuring the safety and efficiency of electrical systems. By working with a professional, you can rest assured that your electrical work is being performed correctly and in accordance with all applicable codes and standards. Taking the time to consult with an electrician is an investment in the safety and well-being of yourself, your family, and your property.